We got a special delivery, boys. Ooh, my.
Hey guys, welcome back. In the previous video, we finished line boring the heads and we started ordering Valvetrain parts, and as you can see, we've started to get some. In fact, we already opened these, we'll show you, but we just got a box today. These are the springs, so we'll show you those here in a minute. We're actually going to unbox those for the first time. So,
All right, so first, let's start with the supporting hardware here. We got all Ford GT lifters and rockers. The lifters have a bigger hole than what comes in the C head stuff, so that's an upgrade. Again, we had to get 40 of these guys for this build, so everything comes in packs for 8, so that makes it difficult. Here are the followers. They're slightly different geometry, and they have these like retainers there to keep it on the spring. So got those. V10 seals to go on there. We actually got new bronze bushings.
where are those?
In the freezer. We also got bronze valve guides, so we're going to be installing these in this video. We decided to upgrade from the metal ones that are stock. So I got a shitload of those. And then moving over to the serious fun stuff here. So Ferrea valves, intake and exhaust valves. Ooh boy. So this is their 6000 series valves. They're stock size. We kept the stock three lock groove, so we'll be using stock style keepers. They have undercut intake. And the exhaust valves are very similar, stock size, three lock groove locks. So those will be going for a valve job with the head. And then we just got in these today. We haven't opened these yet. These are the springs from Crower, so let's go ahead and see what we got in this guy. Oh, Diego's excited.
I want to help too.
Get these open.
Oh, there's a box inside a box.
Boxes. Oh, okay.
That's good. So these are the chromoly retainers.
Yep. And then
And all the springs.
beehive springs. These are ovate springs. They're higher rates. So those should help us rev to our goal. So with all that stuff, like I said, we got to put in the bronze valve guide, so you'll see us doing that. Then these heads will be ready, finally, to go to the machine shop and get the Ferrea valves put in and all the stuff ready to go.
We're going to be using Jack's new toy.
We're breaking this thing in on this project.
You got a mill.
I got a Herco 1992 vintage mill. It's a CNC 3-axis. You control it, from this
Very
high-tech
Very high tech.
center here. So what we're going to be doing is we actually did one head, and we'll be showing you the other head. We originally started just wanting to clean up the welds, but then it looked too pretty, so we resurfaced this this face. We'll be taking this down, cutting out the welds from the bolt holes so the bolt holes sit flat, and then we're actually cutting the deck face, so we're going to cut that down, make sure there's no porosity, and if there is, weld it back up and just keep going to make sure everything's clean. So we'll be showing you that now on this bad boy.
All right, so we're all done milling the heads. Everything came out okay, like we said. Just a little bit of porosity here that we found, so we took it down, and Jack is gonna work on re-welding that, and then we'll face it one last time, and then we'll be ready for the guides. We'll press these out and start working on getting those in, and the heads will be ready to go to the machine shop. All right, so the second to last step with the heads is gonna be replacing all the valve guides. So we've bought a set of bronze valve guides we're gonna install, and now we got an air hammer. We bought a driver that's sized for our valve guides. So it's a pretty simple process. You essentially get your driver in there, press them out, and they come out from the other side, look like this. So we got 40 of these to go, so we're gonna get hammering. That was probably some of the hardest work we've done so far. It's not as easy as they make it sound in the videos.
All right, so we just finished pushing out all the valve guides. They were harder than we expected, but we put some heat on it, and that really helped. So now before we put in the new bronze ones and get those finalized, we've decided to go ahead and do some porting. So we want to take this to the next level. So we're going to be cleaning up all the surfaces, knife edging the dividers, and then raising probably the ceilings of the ports up on both the exhaust and the intake. So we're going to be doing some research as well to see what other people do, what works on these 4 valve heads, and then trying to incorporate that here. But that's going to be the next step until we get those going. So some of the tools we'll be using is these Quality Harbor Freight sanding drums, and then we have long carbide bits to get deep inside the port and clean it up in there. All right, so we've been working on porting the head, but we don't want to just port just for the sake of porting. We want to set some metrics and collect some data, and we have some information from posted online about what a stock head should flow and what a ported head is able to flow. So we're really going to try to get within 5% of a ported head flow. So to measure the flow rate of a cylinder head, we have to have a flow bench. So what we did is created a flow bench, and this is available online, these schematics, but here is a simple drawing of what a flow bench is and what we put together. So what we have here is a cylinder head is going to be mounted onto a chamber. This chamber is going to be sucked down by some vacuums. These 2 vacuums will be pulling air from that chamber where the head is mounted to, sealed. And then we're using an LSGM map to measure the amount of flow through here. And it's connected to a computer with an Arduino to measure temperature and grams per second flow rate. It actually outputs frequency, and that frequency is converted to grams per second. We have a bypass valve that allows us to set the depression based on the valve lift, and we read the depression based on the manometer reading. So this is a small U-tube manometer that is connected to the chamber basically to measure how much vacuum is in this chamber. And the goal is to set the depression to 28 inches. That is the industry standard for flow benches and measuring cylinder heads. And in this, we need a 28 inch here difference between the water levels. So you set the water level. When you have vacuum here, it moves this level up, this level down. You need 28 inches between them, and that is equivalent to 28 inch depression. Then once that is set, we're able to measure the airflow with the MAF, and that will give us a direct comparison to a catalog number specified by somebody. So this is in theory, and then this is in practice. So we have the head mounted on a table. Here we have that chamber I showed connected to the MAF. The MAF is connected with an Arduino running to the computer, so we could output and see flow rates. These are the two vacuums we're using. This is the bypass valve that we'll be able to set. So we'll be adjusting this based on this U2 manometer reading. So you can see the level here. Once we turn this on and suck it up, this level will move up, this one will go down. The difference in those two levels gives us the depression in the chamber. All right, so what we have here is a piece of the stock head, untouched ports. They're as they came off the aviator. We're gonna set the lift to 0.1 inch and increment it up by 0.1 inches up to 0.5 inches, collect the data. So we're gonna set the depression to whatever we are capable of, and then we'll be reading the MAF. So the MAF will be read by the Arduino, and the MAF is actually reading in frequency. So the Arduino is reading frequency, but we relate frequency to grams per second via a exponential curve that is available for a specific MAF. Once we know the frequency and know the grams per second of air flowing, the temperature is also read by the MAF. The temperature is being determined from the Steinhardt equation. 0.2514 times the CFM of the flow of the head. Once we know rho, we're able to calculate CFM via the relationship of grams per second. So we were doing some testing, like, oh, maybe if we raise the floor up. We were getting experimental over here. Let me tell you a lesson we learned. There's a hole inside of there, the spark plug hole. Turns out air could go through that.
Yeah,
and we just figured it out now after
how many sets of flows? We've been at this for a couple days now.
probably 15 data collections, all trash.
Damn it. Yeah, so if you're flowing heads, plug your spark plug holes. Jesus. Alright, so we're back at porting. This is day 3 or something. We're at this point we're trying anything we can to get gains. So we just tested, we hadn't done this before, but we cleaned up the chamber. So it may be a little hard to see with the valves there, but we cleaned everything up, made all the sharp edges smooth. We got rid of any kind of weird transitions. And we just flowed this and it helped at the low end. So it gained about 8 to 9% from 0.1 to 0.2 inch lift. So we know this works. Next, we're going to try racing the roof of the port. We're hoping to find a way to gain at the top end, like 0.3, 0.4, 0.5 inch lift. If we can put that together with this and just blending the bowl, we're hoping to get close to 15% improvement over the stock heads. So I think we're almost there. Just a couple more things we got to try, and then we'll start porting or finishing up porting the actual heads. Alright, so this head is done. All the ports are cleaned up, sanded smooth. Jack just finished polishing the chambers. So now we're gonna flow this one last time and we'll show you guys the results when we're done. Alright, so we're finally done flowing the heads. It's been 3 weeks of porting, but polishing. But we finally have some consistent data. Our heads flow within 1%, something. Really. They're super close, so we're gonna compile all the data and we'll show you guys the results.
Alright guys, so what we're going to do now is show you actually the data we collected, and what we're going to show here are the things that gave us the biggest improvement. So what we're going to start with is, this is the baseline flow of the stock head. So the stock head is what we measured in blue there. That is what we put on the bench, flowed it, and then what's in orange is the motor trend data that's available. So what this is just showing is our bench in our setup was able to collect data that reflects what is collected by a bigger, industrial setup.
All right, so this first plot is the first step we took on the intake port. So the 3 steps that we're plotting here is we started by racing the sealing of the port. We sanded everything smooth, got rid of any casting imperfections, parting lines, things of that sort. And we also sanded the bowl, blended the bowl with the port. We didn't touch the short side of the turn, and the floor we left somewhat rough. So this was just just cleaning up the port essentially. This step showed a really significant improvement, and we knew that we were heading in the right direction.
All right, so this third one here we're showing in gray is that we sanded the short turn. So prior to this, we didn't touch it at all. It was as cast. We cleaned that up with some of the drum rolls and smoothing that out, and that actually did net a pretty good improvement for just touching that small area of the short turn. That did give us some at the higher end flows you can see here. So now we'll go ahead and look at the next step we took. So this fourth curve here in the yellow is the last step we took, and this was sanding the chamber. So getting rid of any weird transitions, de-shrouding the valves. We didn't fully polish it, but we did sand it smooth. So the biggest thing we noticed with this curve is the shape change. So if you look at all the other curves, the slope and the shape of the curve stays the same versus the stock head. Yeah, they all have like a knee at 0.3 lift. Right. And that sort of seems to go away when we do this chamber work. So you can see that if we just look at these numbers, we actually lost a little bit of flow at 0.3,
but gained everywhere else. So something's happening at 0.3 inch lift, and we're theorizing that it has something to do with the fact that we don't have a valve job yet. So we're thinking about reflowing these heads once we get the valve job completed, and hopefully that will tell us what's going on in that area.
Hopefully it helps it, because we did all that work.
Yeah, we don't want to lose at that point, but
it did help on the low end and the high end. So, you know,
it's one of those compromises, right?
Yeah.
All right, so this last plot here is our actual heads fully ported. So we took all our findings from the previous tests and we went ahead and finished everything up in our heads.
The reason there's two here, also two heads, is that we actually split the work so we could get done quicker.
Yeah.
Diego had one and Roger had the other.
And as you can see, we got gains everywhere. The first thing that you notice is that, excuse me, that the shape of the curve is exactly the same as what we saw in the previous test. So it still maintained that slope change at 0.3. So at least that's consistent, which again, we'll find out once we get a valve job what happened there. But regardless, we saw a pretty significant improvement all throughout, and more specifically at the top end, which is what we wanted. So based on these numbers, we improved flow at the top end by about 15%. 15.3% is what it equates to. So we're happy with that. I don't think we could do much more to get more gains here. The one thing we didn't do for these heads is raise the ceiling. So even though we tested that and we saw good results, we decided that it wasn't worth it. We didn't want to deal with having to go with different gaskets for the bigger opening. So we left it stock.
And it showed, I mean, it has similar flow, so
yep.
it wasn't really that big of a factor in why it flowed well that other time. So. Right. All right, so then now what we're showing here is the exhaust flow. So the exhaust, we didn't take as systematic of an approach. We just went at it. So we didn't affect it too much. We raised the ceiling a little bit. What we did is looked online for some other people who've ported heads and sell these heads, and they raised that as well. So we just followed that trend and then cleaned up all the casting marks and roughness in the port. And it netted us some decent results for not going too deep into it. We improved about 11-12%, so that was a satisfactory gain for us. This concludes all the porting then for these heads.
Something to keep in mind, you know, this is a good set of data for reference for anyone that's porting these heads. But obviously these results reflect our setup, the conditions of our setup. So it doesn't mean that if you follow the exact same porting job as we did, you'll get the same results. You know, there's going to be plus and minus here and there. But ultimately, I think what we got out of this 3 weeks of porting is that you want to check at every step if you have the ability to, because there are things that you could do that will hurt flow. So if you have the ability to build your own rig to flow your heads, do that, and that will teach you a lot. Okay. All right, so we have the heads ready to go. We're going to get started installing the new valve guides. The first step is going to be cleaning the bores. So we have some cleaning brushes. We have all our tools laid out for the rest of the process. We have our driver, which we showed you. We used to press the old ones out. We have a reamer. We have also a honing brush, and we did get pin gauges to make sure we get the right dimensions and clearances for the valve guides. So let's get started.
All right, now that we've finished all the guides, we're going to go ahead and start reaming them out to the correct diameter. All right, so we got our honing tool attached to the drill. This is a 240 grit tool. This is just like a miniature ball hone. So we'll be running this through the bore about 15 times, and then we'll check how it fits with the pin gauge, and keep doing that probably at 5 passes at a time until it fits well. All right, so we finished the valve guides. Everything's in place. They're all honed to size. The valves fit in there. They all feel very good. So the next step now is going to be taking this. I know sounds like we've said this many times, but we are actually now ready to take the heads to have the valve jobs done and getting this bad boy decked and all cleaned up. When we get them back, they're going to be ready to be bolted on an engine. So we're going to get all our parts together and take them over to the shop. So thank you guys for watching, and we'll see you on the next one.
All right, if you stuck around till the very end, we're going to show you a sneak peek to the next episode. We're going to be working on the intake.